Hello everyone, this is Ram Perumal here, and good evening, and welcome to the second webinar regarding PVSYST and software systems. And in today's session, we're going to go over how to design a 3D system within PVSYST, or how to, say for example, you have a system already done, if it's a ground mount pixel system or a single axis tracker system. It's always good to have a complete shading analysis done through PVSYST. And in general, what we do with PVSYST is we take all the details from the layer. Say, for example, module type, module has new filling and things like that. But we don't do a complete shading analysis. We just enter those details. We just say how far the modules are, and then we run a simulation. Right? But in today's session, what we're going to do is we're going to build, or at least try to build what we have. In terms of the CAD layout or in SketchUp, we try to build that within PVSYST, and then we are going to run a simulation. So, I'm assuming you all are aware of what this page is. This is the very first page that you see in PVSYST, like once you open the software. And since we are designing a grid connector system, I'm going to click on the grid connector option. And I'm going to, usually what happens is when you have a couple of different projects that are already designed or done within PVSYST, you could just use the search button here and then look up for your project. But what I'm going to do is, for today's session, I'm just going to create a sample project, just for the sake of it. So I'm going to call it sample 3D. I'm going to name it sample 3D. And then for the location, I'm going to choose Chennai for today. So I'm going to go click on Asia, and then search for the location I want to design the project, and then I choose on Madras. So it's here. And then I do that, and then my initial project setup is done. Don't worry about what we did here. It's just to start a project. This is not something that we are concentrating today. So once I do that, and then for example, all these details are already filled in, or if it's a new project, what I'll do is, I just click on system, go here, and then say, for example, enter a 1 megawatt system, or say a 1.3 megawatt system, and then choose a module type, and then I choose a inverter type. I'm not going to change any of these. I'm just going to click on OK, because we'll come back to these later when we run the simulation. So once you are on this page, you will see something called this near shading. Right? This is where in PVSYST we go and draw the 3D shades. Click on this, and once I go to this page, I have an option here which says construction and perspective. Right? I'll click on that. So since I already have some design here, it's showing up. I'm going to delete all these. I'm going to remove everything in there. I'm not going to leave any of the existing design there. We're going to start from scratch. So once you are on this page, this window is kind of familiar to the people who have been using AutoCAD, right? This is like a 3D space where you can draw certain things and use the mouse and pen and view all things. For now, what we'll do is we just have a top view. Clicking on this button over here, which is top view, and then you have view from the front, and then you have a side view. But if you want to see like a perspective view, you would click on this button, and then you could do something like this, right? So we're going back to the top view, and then in this window, we'll just go over. In this window, I'll just go over what all functions we have at the top, and then we'll start with the very basic PV. So within file, you will see certain options that says create a new scene, read a scene, read buildings, and read objects. Since we are starting a new project, we'll start with new scene. Let's just go with a new scene. And if you already have a design, say for example, you have a design that you've already done, and you just want to import that in, then we will go and choose the read scene option. But for now, since you're starting from scratch, we'll just leave it as it is, and then we'll move on to the other tabs. So you have something called as create. So this is the option that you use to create anything, be it an abstraction, a thing that would cast shadow on the modules, or be it for creating the whole module system. Let me just show you a quick layout that we would try to replicate it, or at least try to do something closer to that. So what happens is I'm going to show you a fixed fill system. I hope everyone is able to see the screen of a new layout that I'm showing. So this is a very basic fixed fill system. It doesn't have a lot of details in there. What you see here is, as you know, the blue color ones are the PP modules, and this is a ground mount fixed fill system. And you could see, if you could zoom in closely, you could see this has like two modules. It's a two module racking system, and then we have the azimuth, and as it's perfect south facing. So azimuth is 180, and then we have a tilt angle of 25 degrees, and then we are using a Hanwha 390-watt module. It doesn't matter. We'll go and choose all the modules and things like that later. So this is the sort of layout that we are going to try creating within PVSYST today. And let's see how we go over the process. So we are on this page. As I said, we are going to click on top view for now, and then I'm going to use create option. This is the one that we will be using mostly within the whole 3D scene. So I'll just show what these things are. Within PVSYST, for creating shading objects, you have two different options. Like one is called as an elementary shading object, as the name suggests. Another one is called as a composed object. I'll just show the differences between the two. In an elementary shading object, click on that. So you get a pop-up window like this where you will be able to create any of the objects. Let's say, for example, a rectangle or a square or a cube or a cuboid, a triangle, anything like that which has some size to it and then some height to it, so that it's going to cast shadow of the PV point. When you're in this window, you could see it's all, it's kind of transparent. So it's very difficult for us to see what the faces are. So what I do is, there is a button here in render. So I will click on that. So, it becomes a solid object so that you are able to see all the face. And if you think this color is, not pleasing to the eye, then you can click on this option and then probably change it to something, um, you know, uh, something better, take a break. What I would suggest is kind of keep it bright for now, because when there is a shadow, that's always going to be either gray or closer to gray. So I would keep it something like say orange. This is what we have. And then you can see this is they call it the pad paper. And if you want to change it to a different object, you have a couple of different options here, right? It says parallel paper. This is the one. Say, for example, if you have like a rectangular building in front of your PV array or in front of the building, and you want to define that particular one, this is how you do it, right? You can define this one, say, for example, 25, this is like 35, and then you can define the height of the building. Say, for example, if the building is 100 feet tall, then you would be giving something like 33 meters. Right? So this is how your building would look like once you create it. For now, what we'll do is, let's assume that we have a building right in front of a PV array, and this building runs for say 50 meters in length and about about 10 meters in width, and the height is about say 50 feet. Okay. So what we'll do is, in terms of it really depends on, like, if you look at the width here, it says dx. So like when we draw any 3D image, what happens is x is what we call as length, and y-axis is what we call as width, and then height usually goes in the z-axis or z-axis, right? So don't worry about width and length being changed. Whatever we like, dx is our length, so I'm just going to keep it at say 50 meters, and then I'm going to call the width as say about 10, and then the height is going to be say somewhere in 25. Right? So we have something like this. This is how the building is going to look like, and we are going to build a PV array over here, in here, and then see what the shading losses are. So I'm done. I'm done with this. I'm going to click on close. So you can see this one comes in. So I'm going to click on render. So you can see this is how the thing looks like. This is the top view. You can see this is how the whole building is. But what we wanted is we wanted the building to look like this, go in this direction. So what happens is I can double click on this one and then go back and change the measurement so that it comes exactly like the way we wanted it. Or what we can do is, I'm going to go back to the top view again. So what we can do is you can use the options over here, modify options over here, and then you can rotate the whole scene. So for example, I'm going to click on this, and then I'm going to click this rotate option. So you get an arrow. I'm going to use the arrow and then drag and rotate it the way I want it. But for now, I'm just going to leave it as it is because I don't want to change that one right now. So you're in this one. Once you create that kind of shading object, you can kind of rotate and see how it looks like. This is going to be the top view. This is going to be the front view, and then you have a side view. But we'll just keep it at perspective for now, so that it kind of gives us an idea how it looks like. So what happens is, well, once we created this, we can go back to the elementary shading object, and then I'll show you what other objects we could create within PVSYST. Right? This is what we did right now. And then say, for example, you don't want to do that, you want to create something like a pyramid, right? This one lets you create something from 4 edges, right? Or some object that has 6 faces. Right? But let's say you want to create something that has only 3 faces, like a triangle or a solid triangle. In that case, you cannot use this option, right? You cannot use this option because there is no option for you to go and delete this. So what happens is we'll have to use the square pyramid. Yeah. This one kind of gives you, let's say you are designing you want to see how the shading from a church affects your PV array, then obviously you would need an obstruction like this that you create on top of another building so that it kind of it gets closer to how a church looks. Right? This is one thing. All you have is like a base. You can give a base of say 5 meters and then a height of say another 10 meters, and then you end up with something like this. Right? So I'm going to click on close so that this thing is also getting added to my design here. But what happens is, as you know, these two buildings cannot stay closer to each other like this. It's kind of merging into one another. This is not possible. So what I'm going to do is I'm going to click on this one, and then you see you can see that the rotate option is already highlighted, but I don't want to rotate it now. I want to move this to a new location, right? So what I'm going to do is I'm going to use the option closer to it, which is called as the move option. So I'm going to click on that. Once I click on that, you can see I get an arrow mark here through which I can drag this object. So I'm going to click on this and then pull it here. But what happens is, like, once I click on move, you can see I get a mouse or a pointer here, which I can click and drag, right? And you can see it also has 3 faces here. It kind of shows. So once you move the mouse, the plane changes, and I get a small note right next to the mouse. It says move on X or Y plane. So that means I can use this one to move my object in the X Y plane, right? And then I have an option here which says you can move some object on X or Z plane. So it means I can move on the Z plane, meaning I can increase the height of it. So you can see this is how I can move things, right? So what I'm going to do is I'm going to keep this one kind of here, and then I'm going to let's create a PV module over here so that we can see how the shading from something right in front of it and something from from the east side of the array. And let's say you want to create multiple objects of the same size, you don't have to go and create it again. So you can just use Control C and then Control. You can copy and paste just like you do in say a Word document or anything. You can use Control C and Control V and you can copy and paste it. So I'm gonna paste multiples of it and then create objects as I want. Right? And then I'll show you what other objects we could create, and then we'll create a reasonable drawing. Right? This is not something. This is not a place where we usually go and put a PV array. But just because we are going through all the options, just bear with me with all the things we do. So, okay, so we've seen those two options, and there is something called a triangular prism. So this one, the other one was a pyramid. So this is the triangular prism where it has only 3 faces. So you can, either drag it, you can make the angle change, then you can move the way you want it. And then if you want to create something like this, then this is the option you use. And then you have similar thing, you have like a hexagon, you want to create a cylinder. If you, let's say for example, you want to create electric tower or electric pole or something like that, then you would use this option, right? But what happens is you can see, you click on the option that says portion of the cylinder, and you can see the radius is 1 meter, and then it says aperture angle is 180. But the object that we are trying to create here is a cylinder, or it's a pole. So obviously, since it's a cylinder, it's going to be 360 degrees. So I'm going to create on 360 so that I have like an entire cylinder, right? And then it asks me for number of segments. Right? Even though the whole angle here is 360, it makes a whole circle, but you can see it still has faces on it. It doesn't look like it's a cylinder. So what I'm going to do is I'm going to make it as granular as possible. Since it says 9, probably I'm going to break it down to say 36, so that it doesn't let me to go till 36. I'm going to go to say 18. So it looks more circular now. And I'm going to use the maximum that it allows me to use. I'm going to use 20. This is the maximum, this is the most circular looking cylinder you could make within PVSYST. And I think it's a good thing that they're limited to 20. Say for example, what happens is when you run a shading analysis, PVSYST, it simulates for every single face. Okay, so what happens? Let's assume you have more than one cylinder. It has to run a simulation for every single phase it sees within the obstruction. So for one cylinder, it has to run the current algorithm 20 times, and then you have a second two, you have a third abstraction. So that's why they kind of restricted it. Kind of, maybe it may not be 100% accurate shading analysis, but this is the best we could do within PVSys now. And I think this is as good as anything that could offer. So we do that, and then I define height. Say about the electric poles that we see here, probably I would say 15 feet, something, 15 meters or something. So I click on 15, so I get something else, right? And then probably I'm gonna reduce the radius to about say 0.5. So I get something like this, and then I click on close, and it gets placed here. Click on this and then move it. As you can see, whenever we create something, we create an abstraction and then you place it on the design field, it always goes and stays in the origin, which is 0, 0, 0. So I'm going to move this one here so that whenever somebody plays something new, we are able to see it right away. Okay. And then let's see what are the options we have within that. Now we have kind of seen all these options. Let's move on to something like a realistic object that we usually face. Say for example, we have a house where we're trying to put a PV system, but we also have a house nearby that might shade our rooftop structure. So what I could do is I could click on this house. So once I click on that, it gives me an option like this, right? If I don't get an option like this, let's say for example, I don't have an option within PVSys that says house, I would have to create a plane for this, another shading object for this. I might have to go create a pyramid and then place it over here, and then I need to create another rectangle and kind of do that, and then I might have to go increase the height and things like that. Instead of going for 3-step process, I can just use the house option here, and then I can define whatever height I want, whatever angle I want, and things like that. So I'm gonna define my width as say 10, and then this as say about 20, and then I'm going to define house height as 10. Okay. And then I'm going to give a tilt for my house for the roof. Let's say this is 115. So it's a shallow tilted house. So something like this, and then you have all these overhangs over here, right? So if I want to increase this, I'm gonna probably increase this to 1 and 1. So you can see this overhang also increases, and this is how my house looks. I'm going to click on close, and this also gets placed here. And you can see, let's say for example, I don't want my house to look like this. I might want the house to look kind of more south facing. Right? In this one, one section of the roof is facing east, other section is facing west. But I'm going to put solar only on one roof, and then this one is going to face south. So what I'm going to do is I'm going to click on the rotate option here, and then I'm going to click on this and then rotate my house. This is my house here. And then let's go back to the shading object again and then see what other options we have. Um, we have, the house is done, and then we have like an asymmetric house where, only one section of the roof is tilted, the other one is flat. But you can, do this and then, build a similar house like we did in the other one. And then we have something like one-sided roof. So these are all objects that once you create this, let's say for example you have like a complex house and you wanna, you cannot do it in one room. So you might have to build so many objects like this, and then you might have to put all these things together so that it looks like the complex structure that you want to build initially. So this is all done. What I'm going to do is I'm going to go to tree now, which is kind of a common abstraction that we see in most projects, right? So let's assume this is a coconut tree, right? So what happens is in a coconut tree, you don't have any branches in the middle. Everything is at the top. So I'm gonna. So you have three different height. Okay. So the very first height is the one from this point to the top. Okay. So okay. So the very first height you see here, which is medium point height, is somewhere over here. So I'm going to change that one to. I'm going to change that one to say about 5. It changes. And then a medium height, I'm going to define this one also as 5. So this one is also high enough. And then I have a lower part height, I'm going to define this one as say 3. And we can see this is how my tree looks like. And then I have this trunk height, which is only 2 meters. That is, I'm going to define that to be say about 15 meters. So this is how my tree looks like. And you can define 0 for any of these parts. So this is let's say build something like this. And then you have this trunk diameter. You can change this one to it's usually let's say 0.25 meters. And then you have this median diameter. I'm going to define this one to say about 5. So this is how it looks like. It's not exactly how a coconut tree looks like, but just trying to use whatever options we have and try to build a place. We're going to go back to the same shading page and see what other options we have. We have done the tree, and then we have something as handrail crossbars, and then we have wind turbine. So this is not very uncommon. There are quite a few places where we also have wind turbines closer to not very close to a PV power plant, but let's say they have quite a few acres of land, and they have a wind turbine that was planned, say earlier, and it's somewhere in the southern side, and then you're trying to develop the area behind it for a PV array. But we're not going to put it right in front, right behind the wind turbine. But let's say we have a PV system that kind of closer that might get shade from the PV from the wind turbine. You can use all the options here, and then build a wind turbine so that it looks closer to what you have in the field, and you want to see what shading it gets from the PV. So I'm going to move this one to the side. So these are all the obstruction we placed so far. Just for the very first simulation, I'm not going to delete any of these. I'm going to leave it as it is. And then probably we can take a look at a realistic view of what we have in the field, and then remove whatever that is unnecessary. So we looked at create and we looked at these elementary shading objects. Let's just quickly talk about what the composed objects are. So if you have something like all the objects that you created so far, you can bring in those, and then you can say You can do all these, and then you can define height for everything. Sorry. So you can define height. You can create multiple objects together, and this is where the composed object comes into play, right? So and it gets placed over here. So you have it here. So I'm gonna delete these now. So once this is all done, now these are all the shading objects we could create within PVSYST. Now we move on to creating an actual PV array. And then if you look at it, within create, you have a couple of different options. It says polygonal PV plane, and then it says rectangular PV plane. Sometimes we might be confused which one we should be using, right? I'll just give you an example of, let's say we are trying to create a PV array on top of this house. Okay. So what happens is it would just be something this big, and then it might have modules within that, right? I don't know what the length and width of this one is, so I'm just going to click on this house, and then I'm going to take a quick look at it and then see what it is. Okay, it says height is 10. I'm not worried about that right now. I just want to know what the length and width are, right? It's 20, and this may not be 20 because the whole length is 20, so I'm assuming this might be 10. But we also have a big handle, so it may not be exactly 10. Let's just stick with 20 and 10 for now, and then we'll adjust it later. While we're doing this, I also want to show you another tool that we could use within PVSYST. There is something, a measure tool, right? You can click on this, and then you can click this. So it gives you a measurement that says 12.12 meter. So this roof measures 12.12 meter, and then in the same way I can measure the length of this. So it goes from here. It's 21.76. So what I'm going to do is I'm going to create a PV plane that does not extend beyond the house we have. So it's going to measure, say, 21 in length and 12 in width. Okay. So let's go to create. Let's go on the top view. I'm going to click on create. I'm going to create a polygonal PV plane. So since my roof is kind of rectangle, I just need 4 points. Okay, I'm going to create a plane that's 4 point, and then I'm going to place all the modules within that. So there are two different options you can use. One is this, where you have to define, like some people might have used logos. It's a drawing tool that I used when I was a kid. So if I have to draw a square, I need to say I have to start from 0 0, and then say my square's length is, the sides are say 5 meters. I would go from 0 to 0, 5, and then I move from 5 to 5, and then I move from 5 to 0, and then come back to the original starting point. Right? This is something similar to that. So this is my origin, and then so the very first line, this one, this is 0 0. So this one, since the length of my roof is 21, it's still the same x-axis, which is 0, but this one will be 21. And then this one would be 21, come on, 21. And then this one would be 21. So you have something like this. Okay. You can either do this or use the module option. And then let's just use the module option, which might be a bit better if you know what the size of the, how many modules are going to place and things like that. Let's say you have a system where your roof has 2 rows of modules, and each row has 9 modules. Okay, and then the modules are also placed in, say, landscape. Okay, so I've chosen, no, let's assume the modules are placed in portrait. So I assume it's going to be portrait, and then I have spacing between these. I'm just going to leave it at whatever it has the default, and then you can see it says modules X spacing. So what it means is how many modules you have in a row. So I'm going to call it 9, and then the Y is going to be 2. And then I'm going to adjust this modules or fill with modules. So you can see this is how the spacing looks like. My spacing needs to be 0.02, sorry, 0.02, 0. So this is all the modules it could place now, but you know, I'm going to actually create a space that's big enough to cover the entire roof. So click this one. I'm going to create a polygonal plane. And the tilt is 30 or 15, just like the roof. If roof tilt is 15, so I'm going to change this one to 50. This one 0. This one it would be 21. This one would be 0. This is not what I want to do. Do you want? So the length is so what we'll do is go here, create polygonal plane from here. So this is the point 0, 0. And then this one, since the length is 21, this one is going to be 0 and 21. Okay, 21, 0, still in x-axis, right? And then the third point is going to be on the same y that we have here. The y is going to be 12 and x is going to be 21. So this is going to be 12. And then we have the fourth point, which is over here. It should have the same length as this, which is in y-axis. So I'm going to leave that as 12. So this is how we end up with the PV plane that's as big as the roof, right? So I've created this. I'm going to click close. This is where we are. This is my PV plane. And since we want the PV array to look bluish, that kind of gives us an idea it's a PV module. I'm going to click on that and then change the color to say something like this. And as you can see, this kind of gets placed on the origin, which is 0, 0, but I want this one to go on top of the roof. So I click on this, try to move this one, and then I'm going to use this option over here and then bring it over here. And you could see it doesn't exactly match with the roof. So I'm going to go to top view and then try to make it as close as possible. Now you can see it kind of stays in the same point, but the tilt is not the same, right? So what I'm gonna do is I'm gonna click on the house to see the tilt. The roof tilt is at 15 degrees, but my array tilt is not 15, it's 30. So I'm gonna change that one to 15 and then close it. Now you can see it kind of, it's still not exactly on top of the roof, but it's kind of closer. So, right? So what happens is now I have a house and then I have a PV module on top of that. But what happens is I'm going to draw a few houses around it, which are kind of taller than the house where we are installing solar panels. I'm going to copy the house and then paste it using Control C, Control V. And I'm going to increase the height of these two roofs. Say this is going to be 230. And leave the rest as it is. Save this. So what happens is we have built all these tools here, which we would simulate shading from these when we do a ground mount system. We're just seeing the very first placement of PV modules, and what happens is we have a house and we want to see what the shading looks like. So once we are done with something like this, you want to see what the shadings are. On the right side window, you see something as called tools. You have something as scene objects, and then you have something called as tools. Within tool, you have an option that says shading animation. So you click on shading animation, and then you have a play button. So once you click on this, what happens is this one gives you an idea of how the shading looks like throughout the year. Throughout the day on 21st December, right? It simulates for every 15 minutes. But you can even take it down to say 1 minute or something, so that you can see how the simulation runs. For now, for the very first run, I'm just going to do it 15, and then probably I'll do a 5 minute interval. So as you reduce the time interval, what happens is the animation kind of takes longer to run the entire day, right? So I'm just going to keep it at 15, and then I'm going to run simulation. So what happens is sun moved from the east to the west, and it kind of cast a shadow. It calculated the shadow throughout the day, and then it has given me this loss percentage. Okay, so when you look at this graph over here, um, I'm talking about this graph. So when you look at this graph, you can see the x-axis has numbers that go from say 6 to 18, and then y-axis has numbers from 0 to 1. So what it means is the x-axis is actually time of the day, 6 o'clock, 8 o'clock, 10, 12, 2, 4 till 6 o'clock in the evening. And then the y-axis is actually the shading percentage, or how much sunlight doesn't fall on the TV model. Okay. So when you take a look at it, what happens is like when it says 0.2, it's actually like 20% of the sunlight is actually not falling on the modules. So what happens is you see a shading throughout the day, and this is the loss percentage you have, and then once the animation is done, it gives you a number. It says 18.4. So this 18.4 is all the shading loss you have throughout the day. Okay, and the shading starts at say around 7 o'clock in the morning, and then it peaks around noon, and then it dies at around say 1 o'clock, and then after 1 o'clock you don't have any shading. You can say that the building is right next to the house that we are trying to place modules on, and then you don't see any shading in the evening hours because sun moves from east to west, right? So what happens is, since this house is actually located on the east side of this building, you have shading in the morning hours, but you don't have any shading in the evening hours, right? So what we are going to do is we are going to keep the same house, but we are going to move the house's location to the west side, and then let's see how the animation changes or how the shading loss changes. Okay, so I'm going to move this house from the way, move this one over here, right? So what we should be doing is just remember the graph that we saw here, where you see most of the shading in the morning hours, before 12, before 1. Now the whole pattern might change so that you don't see any shading in the morning hours, but you will see shading in the evening hours, right? I'm going to run shading animation again. Right. So now you can see the graph now. You don't have any shading in the morning hours, only when the sun is at around 12 o'clock, and after 12 you have a lot of shading, right? So what happens is this is how the whole shading goes. Let's say, but if you have a house on either side, say we have this house, a house like this on either side of the PV array that we are trying to build, the shading loss you would see is going to be both in the morning and the evening hours. I'm just going to run the simulation again. Right. You can see the shading is quite a lot in the morning, and then it kind of drops down till noon, and then again it increases after mid-noon. Okay. You can ask me why the houses, you have houses on both sides, but whereas the shading is way too high in the morning, and then it dies down towards the noon, and then it increases because sun moves in a three-dimensional axis, right? It also moves from east to west. While doing that, it also increases in height, right? During sunrise, let's say for example, people who are in the east coast, you can see sunrise. Like when you see sun at around 6 or 6:30 in the morning, it's kind of low, right? It's low in the sky. But whereas at noon, say at around 11 o'clock or 12 o'clock, if you want to look at sun, then you would have to, tilt your neck kind of 90 degrees to look at the sun, right? Because it has gone high in the sky. This is how the shading works, right? In the morning hours, let's say you have a tree or a electric pole, the shadow is longer because the angle at which the sunlight hits the pole is kind of acute, so that you have a longer shadow. But whereas in the noon time, since the sun is high in the sky, the shadow length is also smaller. So that is what is happening here. The house's shadow doesn't hit the module during noon; it kind of falls somewhere over here. Whereas after that, since sun again goes down to set, towards sunset, what happens is the sun's angle, sun's height in the sky would also go down again, which is called as altitude angle, goes down again, so that you have shadow again in the evening hours. So this is how the animation is usually done. And once, say for example, this is all the PV system you want to build and check its shadow. Once you're done with this, you can just click on close here. Right, once you close that, it has asked me, do I want to update orientation parameters? I'll show why we click this button later. So I'm just going to click on that, but gives me another warning. But what happens is, like, saying for example, if you're done with designing your shading scene, you can just close and then go back and take care of the rest of the stuff. But since we are not done, I'm back in this window. I'm going to, for now, I'm just going to delete all these and then talk a bit more about creating different types of PV arrays within this 3D shade scene. So this is done, and I'm going to go back to this window. So I'm going to, if I want to change any of these parameters, right, any of the PV arrays parameter, I can just double click it, and then I can go to by modules or landscape, and then change this. So if you can see, for the plane that we created, we are able to fill in, instead of just creating a PV plane that is 12 meters by 21 meters, you can define how big you want a PV array to be. Okay, so as we mentioned earlier, this one actually takes in so many modules. If you don't want to do this, you can define certain number of modules in x-axis, certain number of modules in y-axis, and then you can change those. But in order to do that, we have to go to a different PV setting here that we'll see next. I'm just going to close this one. Okay, I'm not going to change any of this. We're going to click on another option, that is rectangular PV plane. Right, so I'm going to click on rectangular PV plane. Let's assume we are just creating one rectangular plane now, similar to the house. But what we're going to do is we are going to define it based on number of modules. We're not going to define any size. We're going to say we have so many number of modules in row and so many rows of modules. Right? We're going to do that. So as you see, you have an option here which says, like when you click on this option, you can enter the measurements. In the previous one, what happened is we had to define the whole array in an XY plane, right? We had to say 0, 21, 21, 12, and things like that. Instead of doing that, this is an easier way. If I had clicked on this option earlier, what I would have done is I would just I would click the width as 12, and then length as 21, and then I'm done with that. I don't have to worry about 0, 21, 21, 12, and things like that. And then what happens is you see rectangular origin in the collector plane. So, whenever we create something, it always comes up in 0, 0, right? It's getting placed in the origin in the 3D plane. Instead of doing that, what I'm going to do is I'm going to say I'm going to enter 5, 5 and see what happens now. So, as you can see, each and every box over here is like 1 meter, and then this is the x-axis, this is y-axis. It has moved from here. Instead of getting placed over here by default, my PV plane is over here. So I'm going to double click on this, and then I'm going to change few more options. Right? Instead of the plain tilt is at 15, I could probably change this to say 25 or anything I want. Okay, and then there are a few more options that you could do. This doesn't have to be just one array. If you have multiple arrays, say for example, you have a ground mount system. Okay, let's forget that this is a rooftop system. Let's assume this is a ground mount system where you have say 10 modules in one row, and you have 3 rows of modules. So you have 30 modules for each and every block, and then you have 10 blocks like this. Okay. So I'm just going to explain again what we try to do here. So we are going to build a block like a ground mount system. Let me show you this. So we are going to build something like this. Okay. So what happens is, let's count how many rows we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 rows, and then I'm not going to worry about how many modules we have in this side. I just know I have 9 rows, so I'm going to go back to the design. I need 9 rows, right? And then if we go back to the design again, I have only 2 modules here, right? So I'm going to do that. So we have 2 modules in this side, and then we have 9 rows, right? So I'm going to double click on this. Number of rectangles, my number of rectangles is going to be 9, right? And then my tilt is going to be say 25. And then I don't know what my length and width are, but I know how many modules I'm going to place there. I'm going to place 9 modules in row, but whereas I'm going to have 2 rows of modules. So I'm going to click on 5 modules, and then I use the option that says number of modules in x-axis. It's going to be 9, and the number of modules in y-axis is going to be 2. And then the module orientation is portrait. So click on these two. You can see the area that I defined is way too big for the number of modules I'm trying to place. So what I'm going to do is, I have an option here which says adjust to modules. So when I click on this, what happens is my PV plane size changes to the number of modules that I have defined. This is done. Okay. And then I'm going to go back to this, and then I'm going to click on close. So what happens is, I get all these. Oh, sorry. For now, what I'm going to do is, I'm going to move these to the side. Click on this. So now the area that we are going to build arrays is kind of free. I'm going to click on create. I'm going to go to rectangular 2D plane, and then I'm going to define the size for 9 modules by 2 modules in a row. Click on adjust to modules. So this is all I have, right? And then the number of triangles I have here is actually 1. I'm going to change this one to say 10, and then I'm going to click on close. Now you can see I have these many arrays here, but you can see they are in a step formation, which is not what we intend to do. So I'm going to double click on this one, and then see this option over here, and then so we have this. So that once you give a tilt like that, so what happens is, it kind of brings multiple arrays where you kind of increases the height of say 15 inches. But we are not going to do that. We're going to probably change this to 0. Once you do that, it's all in a flat plane, right? So I'm going to close this one, and then it kind of staggered at a certain angle. So what happens is, the very first one goes in 0, 0, and then the very first one is at 0, 0, and then it staggers itself so that the other things are out of the way, right? But what I'm going to do next is, instead of creating something like this, what we'll be doing is, we'll create multiple rows of modules where we are able to define the length and width, and what spacing we have between the two, and things like that, right? So I'm going to close this one, delete these. and then I'm going to click on an option that says PV plane with frame, or sorry, PV tables as sheets, right? So I'm going to click on this. It automatically gives me an option where it says, no, it has 3 rows in default, but I'm going to create something like this, right? So I have 9 rows. I'm going to go here, then say I need 9, and then I'm going to give the tilt as 25 because that is what I have in my layout. And then there are two options here which says shed to shed slope, which I'm not going to define right now. But whereas what I'm going to define is I'm going to define the pitch. Pitch is actually the distance from this point. So pitch is actually the distance from this point to the starting point of the second row of modules. So I don't know what the pitch is, so I'm going to go back to my layout to take a look at it, where I have mentioned the pitch as 300 inches. I'm going to convert this one to meters now. So it's going to be 300. It's going to be 7.62 meters. Right? So I'm going to go to pitch and then enter 7.62. So I've done that, and you can see the spacing is all done. But I haven't defined how big this array would look like, right? What I'm going to do is, I don't know how big these things are, but I'm going to depend it on the number of modules. So once I've entered these values over here, I could enter the width and length here. Say for example, width is going to be say 5 and length is going to be 6 or something like that. But instead of doing that, what I'm going to do is I'm going to use the number of modules option. So I'm going to click on buy modules, and my modules are in portrait orientation. So I'm clicking on that, and then for every string, so what we have here is, we are trying to create a block where each and every block is like one string of modules. And string size I have in the design is actually 18. So I'm going to, every block is going to have one string and 2 rows. So it's going to be 2 rows of 9 modules. I'm going to click on 9 and then click on 2. And then I'm clicking on this option which says adjust to modules. So I'm going to click on that. So now you can see I have multiple rows here, and each and every row has 18 modules, and all these are of the same configuration. And I have an array here. Right. But what happens is I actually wanted to build, something like in the PDF. Right? So let's assume this row actually has 10 strings, or say 20 strings, and then these 4 actually has 20 strings, and then we have another 2 rows where there are only say 19 strings, and then so on. So what I'll do is, if I create something like this, I won't be able to go and modify one single row. Okay, I'll show you what happens here. So I've done this, and I know that I need 20 strings like this. Okay. So what happens is I can go here and then change the number of modules. So it's going to be for one string I have 9 modules. For 20 strings I'm going to end up with 180 modules. So I enter 180 here, and then I click on adjust to modules. So I have a whole row of modules here. So this is how my modules look like. And what happens is I'm going to run the shading analysis, but before doing that, I'm just going to go and delete all these so that they don't interfere in the shading laws that we have now. In order to do that, there are 2 ways of doing it, say 3 ways of doing it. You can either go select objects individually and then delete it, or you can use the selection option where you have 2 options, right? You can use a rectangle, something like this, but let's say I want to have a rectangle, but I don't want these two to go, right? So what happens, I can use the random one. So draw something like this and then delete all. Right? Whichever one suits, you can do that. So we have deleted all those. I'm going to save this one. And then, like we did earlier, I'm going to run a shadow analysis. So what happens is I have the PV plane. There are a couple of different 9 rows of modules, and the first row doesn't have anything to shade on it, but whereas row 2 to 9 would actually have inter-row shading losses. So I've done this. I'm going to go to Tools, and then I click on Shading Animation, and then I'm going to go for a top view, and then click on Click. Right. So we have shading losses in the early hours, say before 8 o'clock where the sun is really low in the sky. That's when we have had some shading losses. But, throughout the day from 8 o'clock in the morning till like say 4 or 5 in the evening, we don't have any inter-row shading because we have designed the layout in such a way that we don't have any shading, right? But what I'm going to do is I'm going to instead of keeping it this way, I'm going to reduce my interval distance. So I'm going to keep the modules a bit closer. So I double click on it. My pitch is at 7.62 meter. I'm going to change this to say 6 meters, so that my modules are closer to each other. And then I'm also going to increase the tilts to say 30 degrees, so that they're going to have more shading losses, right? So I've done this. I'm going to change the color of the shadow so that you will be able to see the shadow once it is all rendered. I'm going to keep the shadow at yellow color, close it, and then I go to tools, and then I run the shift simulation. Right. This is not the shadow throughout the day. This is the shadow during the sunset. So don't think this is all the shadows we have. This is in the once the day has come to end. This is all the shadow you have. But whereas if you look at the whole day, the shadow loss is only 1.4 percentage, which is a lot better than what we had on on the rooftop system, which had say about 8 or 9%. Right? So let's assume this is a ground mount system, and then we have a, say for example, a wind turbine. What we can do is we're going to build a wind turbine on the east side, on the south, and also one on the west, and then see how it changes the whole shading pattern. Right? So once we've created the PV array, I'm going to go to create. I'm going to click on elementary shading object, and then I'm going to choose wind turbine. But I don't know, I'm not going to change any of the height or anything. I'm just going to click on that. So it gets placed here. I'm going to move. I'm going to keep one over here, and then keep one more on the east side, and then one on the west. Remember, we have wind turbine, and these are about 40-meter high. And I think the distance is this far. I don't think we would have a lot of shading, but let's just give it a try and see what happens now. You can see the shade pattern kind of falls just like a wind turbine because of all the blades and things like that. Right. So, initially we had an inter-row shading of only 1.4%, I guess. Now the whole shading loss has gone to 2%. So what happens is, because of these wind turbines, the shading loss has gone up by 0.6%, right? So what I'm going to do is, I'm going to probably move these wind turbines a bit closer, and we can see what happens now. And you also saw that because of the sun's height, the wind turbine's shadow might just fall somewhere over here, and that's why we don't see any shadow in the noon time. So I might as well just remove this, and then the one in the east, I'm gonna probably keep it over here. And let's see what happens. So you can see the shading loss has gone up by 2.5% now. From the 2%, it has gone up by 0.5 because the turbines are closer. So this is how we would be able to make a judgment to see if it's if we have a lot of shading due to the wind turbines throughout the day or not. But what happens is initially you would be thinking, if we just saw the report and someone says the shading loss is 2.5% and we have two wind turbines, what we would be thinking is, okay, the whole 2.5% is because of the wind turbines. If we remove those, we would not have any shading, right? But we also need to realize that these modules are all placed in rows of modules. So obviously the very first row is going to shade the second one, and second is going to shade the third, and things like that. So 2.5 with the wind turbines, and even if we remove the wind turbines, we would still have a little bit of shading loss. So we have 1.4. So the wind turbines are responsible for 1.1% of the shading loss, and just the inter-row shading is 1.4. And if someone says, let's say we are working on a design for a tender, and if the customer says that, as long as the shading loss is less than 3%, we are good, then probably we are fine with whatever we have. But if the customer says you cannot have more than 1% of shading loss, then you might have to come here and say the interval spacing is only 5 meters or 6 meters, right? So what happens is instead of keeping it at 6, probably you might have to change it to 7, and then again you have to see what happens now. So if you run a simulation, it will give you like a loss percentage. Yeah. So my overall loss is only zero point 0.7. So 0.7 is less than 1. So I should be good with the interval shading I have now. So this is done. I'm going to close this one, and then let's see another option here. So what happens is when we define measurement like this, when we say the length is so many meters and width is so many meters, it just builds this one. PVSYST builds this one as one string, or it doesn't break this one into a string. Okay, but we all know that we have 20 strings like this, and each and every string kind of goes like this, right? So what happens is instead of I'm going to break this whole length of array into 9 strings, or sorry, 20 strings. That's what we initially said. So I'm going to click on this, and once I click on this array, you see the blue icon over here. This one is highlighted, right? So I'm going to click on this. I'm going to break this one into number of strings. Default in PVSYST, it always comes up like this. It has 4 strings in the lengthwise and 2 strings in widthwise. But in my design, I'm not going to break anything by width. So I'm just going to keep this as 1. But I'm going to keep this one as 20, right? So what happens is the entire length is broken down into 20 strings now. I'm going to close this one, and then I'm going to run the shading loss again. So in the shading component, you would see two losses now. One is the beam loss, other one is the electrical loss. So what happens is, let's say you have 2 strings that are getting shaded, but only the lower end of the house is shaded. So what happens is you have 2 strings, only the lower string gets shaded, so the upper string would still produce energy, right? And this is what you would see as a yellow color number right now. But whereas when you don't have a partition within PVSys, what happens is PVSys assigns the shading loss to the entire system. Okay, let's say you have 20 kilowatt of system, and the upper row is comprised of a string, say 10 kilowatt string, and then another 10 kilowatt string. Okay, so only one 10 kilowatt string is getting shaded. So what happens is the whole system would still be producing 10 kilowatt hours or 10 kilowatt worth of energy every single hour, depending on the sunlight and things like that, right? So that is what we could be simulating with this. So I click on this one. I have broken the whole array into multiple strings. I'm going to go to tools. I'm going to use animation part and then run the simulation. Right. So now you can see the graph where we have two components. We initially saw the beam linear loss, that is 0.7 percentage, which is what we defined already. But now we have like a partition, right? So what happens is when there is like a very small section of, let's say this is one string, right? This is one string, right? When this half of the string is getting shaded, I'm saying that the whole string is useless, right? And that's what happens. Even when this small section of the string is getting shaded, the whole string is assumed to be in the shading loss. Okay, but whereas without the shading, hold on 1 second. So what happens is, you see when I click on so when I okay. What I'm going to do is I'm going to show shading losses between the two with the zoomed in view. Okay, so I'm going to run the simulation again. Uh, just remember the final image that we are going to see here. Right. So this is for the same day, and sun sets on the same place, right? So what happens is you can see that the whole string is kind of shaded, right? But what happens is only this part of the array might be shaded, but it assumes that the whole string is getting shaded, and that's why you have a loss of say 3.5 percentage. Okay. What I'm going to do is I'm going to run the simulation. I'm going to cancel the partition. I'm going to click on partition, and then I'm going to I'm going to click on the cancel partition, close it, and then I'm going to run the simulation now. And what happens is you just remember the very last picture that we are going to see. Right. Now you see the whole image, only this part of the module is getting, so what happens is PVSYST tells you that only this section is getting shaded. So this section would actually produce energy, but in reality it doesn't work like that, right? So that's the difference between using a beam linear loss and also using a string, you also assigning a string so that you get to see what the final shading loss is, right? This is a good one. Like if you this is something that we need to understand. Let's say, for example, you have a 10 kilowatt system and half of the system is shaded. You cannot just say only half of my system is shaded, right? If it's only one string and you say 9 out of 18 modules are shaded, then obviously the remaining 9 would not be producing half the energy that the system should be producing. Those could also be shaded because they are in one string, and we cannot it doesn't work like that, right? If you have like a microinverter, that's a different story. But with the system where you have a whole string of 18 modules, then you don't really produce that much energy. But when you don't partition the whole array into strings, what PV thinks is, okay, only 50% of the overall area of module is shaded, so the remaining 50% is actually producing energy. But in reality, we wouldn't be seeing that much energy from the PPI. So it's always good to have a partition once you're done with the initial array. So we do this, and then I have another thing that I would like to show you. So what happens is, like, since we created this one as a block, this one is all locked, right? So what I would be doing is, I'm not sure if we can do this here, but let me try that one. So I have this one. I've clicked on the block that we created. I go to table zones, right? So once I do this, okay. So this is not possible here. Let's assume I would like to show another thing, like how to create a single axis tracker system. Once we do that, I want to come back to the stable zones and then tell you the other option that we have. Okay. So I'm gonna close this one for now. And so since this was created as one block, I won't be able to go and edit any particular block here. Okay. So what I will be doing is I would have to, if I want to create an array like this, I would have to create 4 like this, and then I have to copy a few more and then paste it over there. So what happens is I'm gonna double click on this. I'm going to change the number of shades as 4, and then I'm going to close it, and then I'm going to copy this and then paste it. Place these ones here, and then I'm going to go on to this one, and then change the number of shades to say, sorry, the number of strings to Instead of 180, it is going to be 162 now. It's one strength now. Just see what it will be like. So it kind of places it in the center. I'm going to move it over here. Right. And then I'm going to copy this one again. Number of modules. So the very first one had 20 strings, the second one 19, but this one I'm going to keep it only, say 5 strings, right? So, sorry, 10 strings. Then, oh, this one over here. So if you want to create a plane, then this is how we would be able to do it. Right? This being a smaller system, it's kind of easier for us to do it. But if it was a larger system, we wouldn't be able to do it. Right? So in that case, what we should be doing is we should be creating something as a area. So in this top section, you have something called as table zones. Once you click on the table zone, you can just go create an area like this, and then you can fill in modules so that you have the exact shape like you have in the AutoCAD design or SketchUp design that you have. We'll get to that part in the end, but for now, I would like to show you how to place a tracker system and then talk about what backtracking and a non-backtracking system is, so that that's the common 3D system that we usually build in PVSYST, so that we don't want to miss that one in today's session. I'll jump onto single axis tracker and then we can go back to the table zones. So I have deleted everything. Why I deleted is because the shading loss we see here, I want to see the shading just for the system that we built. If we had kept that initial house and all the shading loss components there, then we would be seeing shading losses from those numbers. So the study we are trying to do here may not be accurate. So that's why I'm deleting all those. But if you just want to play around, you don't have to do the deletion every single time. So I go to create, and then we did create PV tables as shapes. And what I'm going to do is I'm going to use this option called tracking PV planes. So I click on tracking PV planes, and then I have a couple of different options here, right? So it gives me a 2-axis tracker, a 2-axis frame north-south, east-west tracker, and then gives me a horizontal east-west tracker. The most common tracker that we use is a single axis tracker that has its axis in north south. So I have a next tracker spec sheet here that I'm just going to show you, and we'll try to create a similar tracker here. So first, I would like to show you a layout. So this, I think everybody can see the PDF on the screen now. So this is another very basic layout that we created. And this is the tracker row, and these are all the modules. And I'm assuming we have almost 90 modules in this row. And this very last one has only, say, about 5 strings or, sorry, 2 strings only. So it has only 36 modules here. So what we're going to do is we would try to create something like this. And I don't have the measurement of how far these things stay. So I'm just going to leave it as it is now. And we'll go to PVSYST and we'll try to create this. So let's assume we have a next tracker, right? A next tracker moves from 60 degree to minus 60 degree. So on the east side, the rotation is actually 60 to 60. So what happens is I'm going to use the horizontal north south. So from the image you can see the modules move from east to west. So modules rotation is from east to west. So we need to have an axis in the middle, right? And that is how we need to create the array now. So we choose this option which says horizontal north-south axis. If you're confused, just assume this to be a seesaw that we usually have in a children's park, right? The center point is pivoted, but it goes from the right and left kind of rotates. Assume this PV tractor something like that. So the north-south, the axis that needs to run from north to south, and the modules rotate from east to west, right? So I click on this horizontal north-south or tilted axis option, and then it asks me for axis tilt. My modules within the PV tracker, within the single axis tracker, do not have any tilt. It's going to remain flat, so I'm going to keep that as 0. and then it's facing south, so I'm keeping that one as 0 as well. But whereas my modules go from 60 degree in the east to 60 degrees on the west, so I click 60 minus 60 to 60 and then click on OK. Right. So I come to this window now, and I'm going to open the PDF again to see how many rows I have. So I have a 8, 12, 16. So I'm going to go back to PVSYST again. The number of rows, you can see the whole window over here, which says number of trackers. So number of trackers is actually 16. And then there is no tilt, so that is going to be at 0. I'm not, my rows are all aligned. I don't have to worry about it. I'll tell you what misalign is. You can see all these rows in the same line, right? If I enter one, you can see how this one goes like this. Let's say I'm going to enter -1. It goes like this. So if you want to build something like this, then you use the misalign option. But mine is all staying straight, so I'm just going to keep it 0 and then leave it as is. And there is something called as pitch. This is the distance from this point to this point. What I'm going to do is I'm going to keep that at 5 for now, and then we'll see what happens once we change it from 5 to 4 or 5 to 6. Okay? And then we haven't defined this length. So what I do is you can either use the option over here and then say 90 meters by 10 meters, something like that, or you can use the number of modules option. Like once you do the design, it's all string based, right? What we do is like when a designer gives you a layout, he tries to keep all these modules in whole number of strings. So for this design, I have 90 modules, and each and every string is of 80 modules. So my whole string has a whole row has five strings. I'm gonna define the same over here. So number of modules on x-axis is actually 1, and this one kind of looks like this, and modules on y-axis is actually 90. Once I do that, and then I'm going to click on adjust to modules, click on that, and then I close it. Right, so this is how my module looks like. I'm going to change the color slightly. Let's change the color to something light. So this is how my tracker looks like. Okay. What I'm going to do is once I've created this, I'm going to run the shading analysis. So I'm going to click on play and then see what the shadow loss is. Right. So I have a 4.9% shading loss, and then I'm also going to change the shade color so that it's not gray. Yeah, it's going to be yellow. That's making it in the previous one. And you can see the module moving from east to west, and you can see shade in the evening hours, just like we had in a fixed fill system where the very first row doesn't have any shading. You can see since the sun is from west, the very first row doesn't have any shading, whereas the ones after it all have a lot of shading, right? So what happens is, since the modules are trying to keep up with the sun, and whatever altitude angle or however high the sun gets, it kind of tries to adjust that so that it's always seeing sun, at as 90 degrees as possible. In the evening hours, we see a lot of shading. Right? We are seeing about 4.9% shading. And what I'm going to do is I'm going to change the pitch to, instead of we had 5 initially, what we'll do is we'll probably change this to say something like 8 and see what happens now. see that the shading loss has gone from 4.9% to 2%, right? So increasing the distance between these two rows does exactly what we wanted. It kind of reduces the shading loss. Like I mentioned, in the shading loss that we see here, the 2% is actually based on the total number of area, which is not exactly true. So what I'm going to do is I'm going to click on this one, and then I'm going to break it into strings. And I know that I have 5 strings on each and every row. So I'm going to click on this. In width, it's only 1, but whereas in length, in height, it's actually 5. So I've broken this down into 5 strings. I'm going to close it now. And then I'm going to rerun the simulation and see what the loss percentage is. Yep. So, the 5.3% would be the actual loss percentage, but whereas 2% kind of gives you like an indication of how the whole array is and things like that. So this is done. What I'm going to do right now is within single axis tracker, you have 2 different options. One is called as backtracking, the other one is without backtracking. Right? So the system that we saw here, the default system, is without backtracking. And now what we'll do is we'll try to create a system that has backtracking. Hold on 1 second. Sorry, guys. I hope everyone can hear me now. So I just wanted to, sorry, I've been taking a bit longer than usual, but I would like to, talk about this backtracking because this is a very important thing within single axis trackers. So the simulation that we saw right now is without backtracking option, and we'll simulate an option with backtracking. So what it means is, what you could see that the trackers move from east to west, right? So in the very early hours, what happens is that tracker is going to look something like this. But whereas in the afternoon, trackers will be facing perpendicular to the sky, you won't have any shading. But once you start moving towards evening hours, say for example after 3 o'clock or 4 o'clock, sun kind of starts reducing. Height comes down, and you would see a lot of shading here. What happens is we are trying to increase the production by going for a tracker, but just because these tracker rows are all following the sun, what happens is when the sun is kind of lower in the sky, all the rows behind it are getting shaded. So in order to avoid that, what happens is we use a option called backtracking. So what it means is, the backtracking algorithm, what it does is, it knows when the tracker is getting shaded, right? It has the width of the module, it has a location, so it knows how the sun moves for that particular location. So, for example, if this very first row is shading the second one, the algorithm knows that the tracker rows are getting shaded. So what happens is this one, the algorithm kind of keeps this one as shallow. It doesn't move to the whole 60 degree, it kind of tilts it only 25 so that this one doesn't get shaded. So when you look at the end of the day, if you look at an array like this, what happens if this one would be at say 5 degrees, this one at say 10 degrees, this one 50 degrees, so that none of the rows are getting shaded. I want you to remember the shading losses we have. So we have 2% here and then 5.3%. This is just the shading. And then we are going to use a backtracking option, and let's see what the shade percentage is. So click on this. I'm going to use the tracking parameters. So once I go on tracking parameters, you see an option here that says backtracking. So I'm going to click on that. I'm going to click OK. And then close it. I'm going to run the simulation now. So we have 2% and 5.3%. Let's see what we have now. Now you can see that we don't have any shading losses, right? Because algorithm has done a good job and we don't have any shading losses. And you can see that the module tilt is only very shallow. It's at let's say 5 degrees. Initially we had something at say 60, right? So what happens is if you look at the overall production, you might have say 5% less going with the backtracking option, but you will not lose any energy to shading, right? But if you don't have a backtracking option, you might see the production numbers initially are higher, but due to shading, you might lose about say 2% or 2.3% that we saw here. So with backtracking, we are saving about 2% of shading loss, but we don't know what the final production numbers are. But without backtracking, you might get slightly higher energy, but you will lose 2 to 5% due to shading. So, once you do a final PVSYST report, you will be able to compare what the final generation numbers are, and then you can come to a conclusion whether you want a tracker system with the backtracking option or something without the backtracking option. So I think since we are kind of short on time now, I'm going to open it up for questions. And sometimes if we get to catch up later, we can go over a few of the details that we haven't covered today. But for designing any systems, I think the ones that we covered here is good enough for you to get up and running.
Hi Ram, there's a question from Chandra. So he's asking that how to create shading scene for seasonal tilt and edge set for ground mounted system.
For seasonal tilt, okay. So there are a few things that we could do. If you want to see how you could create, how you could, how to model a shading scene for a seasonal tilt. At this point, you don't have an option to go. Let's say, for example, I'm going to delete the one I have here on the screen. I'm going to open it up for a PV planes a shed. Right. I go here, as you could see, I could create multiple sheds, but I don't have an option to go for seasonal shading. So what happens is, within the 3D shading scene, you may not be able to do it, but what we could do is we'll have to use the orientation option here that we usually do, and then you go here, and then you have an option where you could go for seasonal tilt adjustment, right? So this is the point where this is the place where we could define what tilt you have for different seasons. But unfortunately, within the 3D shading scene in PVSys right now, you don't have an option to do that. So you have a fixed tilt system. You can define only one tilt for throughout the year, and then you will not be able to define two tilts there for different months and see the shading losses. But there is an option for you. Let's say, for example, you have 10-degree tilt in say January. Okay, what you could do is you won't be able to define it exactly, but let me show you quickly what we can do here. So sheds is 3 and shed tilt to say, let's say we have 25-degree tilt for January. Okay, so I'm going to click on 25 and then close it. But in terms of simulating the shading loss, what I'm going to do is we go to tools and we try to run the simulation, right? Instead of doing that, you see there is an option here to choose a date. Okay, so I'm going to click on, instead of 21st of December, I'm going to say click on 15th of January. Okay, and then I'm going to run for January now. So this is how I would run it. Hold on one second. I'm going to keep it a bit closer so that you see some shading losses. Right. So instead of December 21st as the default date, you can move to the months that you want, and you can run a shading analysis, and then you can see what shading losses are. So let's say you have two different tilts for throughout the year, one for the summer and one for the winter months. You can go play around with the shading loss that you see here in the 3D plane, and then you need to go back to the orientation page here, and then use seasonal tilt adjustment, and then use accordingly. Let's say, for example, for January, February, March, 25 did not work. 15-degree was the one that was good enough for you. Just go to 15 and then change it like that. Let's say you want to keep, winter tilt, you don't have to, it has to be higher, but doesn't have to be 50. You can, you found out that say 45 or 40 was a good tilt, then you just go and assign those months here. And that's how you could use the 3D shading scene loss percentages to the orientation page. Hopefully, we should have PVSys come up with an option that lets us choose the various seasonal tills within this window. But right now, we don't have that, and that's the only workaround we have for now.
Okay, Ram, thank you for explaining that. As we are running short of time, so we are only able to take one questions. Other questions we'll answer through email. So thank you all for being here, and thank you, Ram, for conducting such a descriptive webinar. And we'll be emailing you about the upcoming advanced sessions that we are going to schedule from this. And thank you again for being here. We'll ending it.